මහ උදේ පාන්දර කතන හිටියේ නගදින්නේ. උඹට ෂෝට් දාන්න බැලුවා කියලා මොකද? ඒක ඇති බං. මේ පසු.
Good morning. Can you hear me?
Yes, sir, we can hear.
Okay. Eex3417 Day School04. First, I will introduce about Octave. Octave is a open source software for computer numerical computations. And then I expect to explain about entity relationship diagram and the data flow diagram and the software engineering modules, and then use case. How to do the use case diagrams. Octave is an open source language to computer numerical computations and graphics easily. Actually, this is we wanted to explain about MATLAB. MATLAB, it is very difficult to get the original software. So this Octave is similar to the MATLAB, very much similar to the MATLAB, and also it is an open source software. But this software has limited facility than MATLAB. Using this, you can get the answers to the matrix and vector calculations. Actually, I use for this lecture, I use online. There are two types of Octave: online Octave software, and then you can download open source software. This picture you can see from the downloaded software. One is main window. Second is current directory. Second is this is the current directory. Third is file browser. You can check files here, and workspace here, and then the command history. You can type command from here. No, from this command prompt. The main window has three tabs: command window, documentation, and editor. I will go here to open the online Octave software. You also can check by using this Word document. I will copy to the chat. This is the link to this document Word document, Google Doc document, and you can also check try Octave online. When you click here, you can get the Octave software. This is Octave online software. This is command prompt, and this is command history. And using this, you can open separate files to do to type several commands simultaneously and type all the commands at once using this file. I will explain using command prompt first. This is just a calculation 2 plus 2, and then I will try it by 2 plus 2. You can type also 2 plus 2. Here you can see the answer. You can set last answer from clicking this one also. Here you can see the answer is 4. Not only that, 2 multiply, first click here, 2 multiply 5 also you can check, answer is 10. And you can see the history here. And the next one is two sine 2 5 into 2. That is 5 sine is 3.14, and this equation is 2 multiply sine 2 5 into 2. The answer is this one. You can check quickly the answer. You can see the only the last answer from this one by clicking this. And this is how you can create an array. Here in this one array start with a square bracket 2 comma 5 comma 10, and then the semicolon. Semicolon is represent the this is actually 2 rows 3 column matrix. 2 rows 3 columns. First row indicates separate semicolon represent the separation of 2 rows. Here you can see there are 2 rows here. 1 row here, second row, and the 2 and 4 is first column, second column, third column. And this one is 2 into 6, 2 to 6. A is equal to 2 to 6. That means it will print 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. A equal to colon and 6. Here 2 to 4 by 0.3 multiply. The period is 0.3. 2 to the 4. The numeric 2 to 4 numbers between numbers from 0.3 to 0.3 from 2 to 4. 2, 2.3 like that. 2, 2.3, 2.6, 2.9, 3.2, 3.5, 3.8 up to that. And then zeros. This is array zeros, 1 row, 5 columns. Zeros, 1 row, 5 columns. If we put 2 here, there will be zeros, 2 rows, 5 columns. Here ones. You can get here 3 rows, 5 columns, ones. 1, 3 rows, 5 columns, ones. Can you explain what is the row and how many columns here? 1, 5, 6. Hello. Can you say some one? Yes. Not clear. Sound is not clear. Can you chat?
6 column. Hello, sir.
Yes. 6 columns, 5 rows.
5 rows.
Right. Okay. Here, this one multiplied m1 into the m2. m1 m2 put dot here, m1 dot multiply m2. The answer is 4 into 6. We can check what is the what variables values of variables. Type in this one. Here you can see m1 is 2 to 4 matrix. We will check what happens if we type m3. M3 error, M3 undefined dear line. Yes, this is undefined one because these variables are not here. This you can see variables here. And then using file name, I will put these commands in first.m. I will create a file called first. This is name I will put first.m. In Octave and the MATLAB also, all the files are put extension is .m. Now automatically it printed hello world. If you type first here, I will have to save first. Run. Yes. Now first we have to run it here, save it and run it here. Then when you type the file name here, not .m. First, only first. If you write first and enter, it will execute the what commands in the this file. I will put these commands here. Save. Angles. You can see angles here. This command. I don't know whether you can see it here. I can't expand this one. Angles equal to actually this command. Angles equal to 0 to 5. Pi is 3.14 and uh, pi divided by the durations is 0 to 25. Duration of each step is 5/3 from 0 to 25. I will put here 10. I put here 10 and save it, and then first. And there are more durations and more steps, and then you can get more steps here. Y equals sine angles. Now here you can see that y here, and then plot. You can plot a graph, angles and y. Y is y-axis, angles are in x-axis. Right. before run it, you have to save it. Actually, this is a smooth sine wave from 0 to 25, and if you put 3 here, that is plus steps. This is not this sine wave curve is not smooth because less steps. If you put more steps instead of like 20 and save it, the sine wave is smoother than earlier one. Like that, there are several um, mathematical calculations and simulations can be done by Octave, and more calculations can be done by. Actually, there are libraries also. This type, some have developed in files like this for the uh, uh, and then you can buy or collect those libraries. Some libraries included inbuilt in the MATLAB. Some libraries you can buy. One open source libraries are also there, but in Octave, most of them are free. You also can develop M files, your own M files here. That is the introduction of the Octave, because we wanted to introduce MATLAB. That is why we introduce open source Octave. Okay, that is all about the Octave, and then I will explain about how to do the entity relations, how to draw the entity relationship diagrams, because I think in TMA you have to answer with the ERD. One chat is there. Oh, okay. Can you see my screen? It says it is post. Your screen sharing is post. Okay, I will stop screen sharing and again I will start it. Okay. Now you can see the entity relationship diagram, no? Mm, Now, short form of the entity relationship diagram is ERD. Uh, before draw ERD, you have to write business rules. Business rules mean if you consider there are one example, suppose a university offers several courses for a program of study. Students can register in one academic year for 0 or more courses. That means a student may not register for any course. Courses may also exist without any student registered for that course. Uh, Before start any entity relationship diagram, you have to write uh, when in software engineering. Uh, First, there are several phases in software engineering. First is requirement analysis. In requirement analysis, first we have to write what is the business in simple English. That is the first step to implement a software system. Suppose in this example, it is a university registering for a course. There are some rules. They have some rules. There are two. According to this university, one rule is a student may register in one academic year for 0 or more courses. Here, 0 or more courses means student may be uh, register only for studentship, and also the student can get some courses, but a student may obtain by one or more student. A course may be obtained by one or more students. And there may be a new course or old course, no students registered. So that is why this may included. Course may have registered students or not. And also a student may have registered to the program but not have a course. Student obtain mark for a registered course. That is in between that student is there, course is there. When a student registered for a course, he will be get a mark. Finally, he will be get a mark. The following rules also needed to consider when designing a computerized database. What is this? A student has a registration number. normally you also have a registration number, which is a primary key. Primary key is it is a unique key. Now, when you consider a registration number for you, it is a it is only for you. That registration number is only for you, not any other. That is called primary key. This NIC also a primary key, because in Sri Lanka, uh, when we consider NIC in a person, that is called uh, it is unique key, unique number to each person. It should be unique and not null. Not null means not empty. It cannot be empty. A course has a course code. A course has a course code, which is a primary key. Each course code is a unique, and therefore it is also it is called a primary key. It should be unique and not null. Each course should have a course code. Course cannot be exist without a course code. That is why that is a should not null. Entity relationship model consider one about uh, a business role. A student may register for 0 or more courses. Here, we have to consider what are the entities here. There are one more thing I have to indicate. These students and courses are entity. Here, relationships. Each entity relationship diagram should have entities and relationships. Entities we can obtain from a sentence what are the entities and the relationships. Here, a student may register for 0 or more courses. Here you can see student and courses are nouns. Register is an action. Student, the relationship between the courses and students get from the register. The link between the courses and student are is linked happened by registering to the course. So this student and the course is become entities, and here register becomes relationship. Normally, when you write ERD, student and course entities are graphically represented by a rectangle. This register is you can it represented by rhombus sign, this sign. And then here student is entity. Here some attributes are available for each entity. Like student has a registration number, student has a name, student has a gender, student has a age, student has a address. Those these details are belongs to the one student. So they are called attributes of the student. Then what are the attributes of course? Can you explain attributes of course? Can you chat? Yes, course code, course name. Usually, no, we call uh, course title. The lecturer, it is not related to the course. Now, in the course code, suppose EX3417, 3 is a level 3. Now level 3 is a attribute. And then 4 credit, it is a 4 credit course. Now, 4 credit is a attribute. And then some courses are some courses have semester based and in science faculty. Some courses are science. They are doing semester wise. We are doing in year wise. Now, this course is a year wise course. Course duration, yes, course duration, and those are attributes of a course. The course and lecturer is then the lecturer is another entity. Another entity, and there are relationship between course and the lecturer. One lecturer may conduct several courses. One course is may be conducted by several lecturers. Like that, this should be written when you yes, course details. Course details are collectively. Not it is collective of attributes, course details. And then okay now. Now relationships and attributes. Now when we consider here this relationship also have attributes. Now when we consider the student and course, now when you register to a course, one attribute is registration date, who signed, and what are the marks. Those are the register details, details of attributes of register relationship. Registration year. Registration year. Here, other thing is attributes, relationships and attributes. You can complete drawing relationship like this. There are attributes, entity, register relationship. This is a cause entity and the attributes. From these attributes, we choose one attributes as a keyword, that is primary key. We underline this attribute primary key upload. Here course code is a primary key. Now you can see this angle sign. Here also angle sign. I will explain later what is this. Now, when you consider a student, we consider some example. There are 1, 2, 3, 4, 5 students and 4 courses. This students have get this course code. This student has get these 3 courses. Eex3417. These are old course codes. There are 3 courses. These students has got this course, and these students has got 2 courses, and this course uh, no students registered for these courses. This students has not got any course. So these are uh, the, these are called not obligatory. Obligatory, it is a must. Some relationships are there. It should be there. Suppose a program. A program should have a course. Without a course, there is no program. That is when you uh, include this relationship, there is a separate mark we include. Here, these are relationships. One more thing I have to explain. This arrow, like arrow, one into more. Here, this side one and to this side many. But here also you can see one mark, one these lines come to one point. Here also one, here, this one here one, and this side is many. So one is one to many. Here also one to many. So this is a many to many relationship. Many to many is many is this relation. This side. One is this side. This one side is, it is a mandatory. Mandatory means all should be filled. This optional many is like this. Some elements are not related, not linked. So you can you can set it as a zero line. This is one. Mandatory one. One and only one. Here, this link is one to one. This link is one to, 0 or 1. Sometimes not, sometimes 1. This one side. This many side. Here, according to this diagram, you can draw again like this. Here, student, entity, attributes, and these are attributes, and the registration year, and the many to many. Many and not mandatory. And then there but all these entity relationship diagrams, you have to convert it to the data tables in the database. When you do the lab 3, you will learn about tables, database, and all those things, relationships, and so in a practical database like MySQL, only one to many relationships are there. So here this register one relation is mark sheet. In mark sheet, registration number is there are 3 tables here: student, course, and the mark sheet. in mark sheet, you have to link it with the student registration number, course code, and the registration year and the mark. And here, one course has many mark sheets, many marks. One and the one student has many marks. So here the relationship is student to mark sheet is one to many. Here course is also one to many. This is called associate entity. You can get the associate entity from the relationship. Here like this. Student S1, S2, S6. Course, there are 4 courses. Marks, this student has this mark got for this course. This student has this mark, has got this mark for this course. This student has got this mark for this course. Like these students have not registered for any course. There may be a course not registered students also. So without any link, there may be course without any link. Oh, can you understand? Are there any questions? Hello. Did you understand up to now? Okay, okay. Now, that is okay. That is the only thing how to get the you can by this relationship you can get the data tables of a database because you can collectively you can type this as a registration of student course like that. Uh, uh, Actually, in a real database, not like only one entity relationship diagram, there may be uh, different entity relationships collective. Okay, now this ERD section is finished. Now database. Database I will explain by in our book. Data flow diagram. Here you can see in the first book in page 75 uh, a lesson available called data flow diagram. You understood what is the entity. Now, in data flow diagram, there are two entities between two entities. How data flows between two entities. Uh, between two entities, just without any process, no information flows from one entity to another without any process. Therefore, between two entities, there should be a process. When you draw a data flow diagram, uh, before you draw a data flow diagram, complete document should be there. What is happening to the in company or institute or somewhere? What is happening? There should be a complete document. There will be two data flows diagrams, existing and the design one. First, we draw the data flow diagram, also actually ERD also, and the data flow diagram also. X is for the existing system of the company. First, we write it as a context diagram, because suppose we want to implement a software system for item stock management. So process 0 is stock management. We main external entities to the system. We identify what are the external entities, and from where to where the data flows from where to where, and we draw first process as process 0. It is a context diagram, only one circle. Actually, in the data flow diagram, there should be these things, these symbols are there. This is entity, external entity, a source for input or output sync. This circle line is process. This is data flow. This is data store. This flow input, this flow output. This is another example. A simple shown in figure. External entities are customer and company. External entities are customer. The customer gives voice and numeric data to the telephone call system. Therefore, it becomes a source. Company receives necessary messages from the system. Therefore, it becomes a sink to the system. Like this, we can draw the context diagram like this. Source customer, sink is company. The data flows only from customer to the company according to this diagram. Okay, now it is not really happening, but for easy understanding, we draw like this: voice to this system, telephone number to this system, telephone call. This is a process, and the company and the database. Levels of DFT. After writing, after drawing context diagram, we expand this to the level 1. Level 1, we have several processes, divide some sub-processes and save external entity to the external to this external entity 2. External entity 1 and external entity 2 is always same. But actually, when you draw data flow diagrams and also other diagrams, it may be changed. But theoretically, it should be one external entity and external entity 2, and from that only these processes are goes. We can clearly draw if these are same. But when sometimes when you draw the second level one, uh, you may need to add another entities. That is practically what is happening. And then level 2, this subprocess also divided into processes. So we number this context diagram number as 0. This process, these are numbers as 1, 2, 3, 4, like that. And then this process are in below levels, same external entity, and the process process become 1.1. Here 2.1, 2.2, like that. Here this one, for this one 3.1, 3.2, like that. The same outputs should goes to the to outside from the process 1, but really it is not happening. When you go to the level 2, it will there may be more than 2 lines. So you may have to draw it from the beginning. This is one example level. What is this level? Can you explain? Anyone explain what is this level? How to identify levels? Hello. No. Anyone can explain? Like this, when you see like this, what is the level of this diagram? Anyone can chat, at least a chat. Not understood now? Hello? Yes, level 1. Only one student chat. At least one order processing. Yes, no, level 1 actually. This diagram is level 1. Level 0 is context diagram, and then 1, 2, 3, we call it as a level 1 diagram. Please talk also, at least one, okay? Otherwise it is lazy for me also. And from this, what are the entities here? Can you check what are the entities here? Customer, yes. Customer and warehouse, yes. Yes, that is, yes, those are the only two actually, customer and warehouse. What are the processes here? Processes, order process, yes, okay. Now, okay, enough. Collect payments, collect them. Stores are orders, customer also, and invoice are the stores. Okay, now. Now here customer details are here. Customer details include customer name, customer address, telephone number, like this. Invoice details. Invoice details. Here you can see the invoice details here, and the invoice details are invoice number, customer name, customer address, like this. Like that, several other data flow diagrams also there. You can read books for these. Usually, when you draw up to level 7, that is enough. Usually, in practically, level 7 means up to the level 7, you have to draw the up to 7. When you draw the up to 7, that processes will become manageable components, because it is very easy to manage simple modules. Those are called modules, and this is the calculate commission. These modules you can implement software program pieces. It is very you have to design software code for simple programs, and collection of all these programs become a large system, like this. Calculate commission. This will become very easy to manage, and then you can implement it as a software program. Okay, that is also that. Now, next one is software engineering. Software engineering is before emerging software engineering, some have developed softwares, but most of those software initially actually there were no big software systems like order processing, and there are in every area now there are softwares in art, medicine, business, any military, in all those fields, agricultural, all those fields, there are softwares. To design a software, you should have clearly design those things. Otherwise, all those softwares will be fail. Actually, even we design using software engineering tools, most of the softwares are failing. So it is very difficult to design and develop and implement real software. All the software designed software should be re-engineering and re-implement after about 5 years. This why software engineering need recognize the need of disciplined approach. Software system developer understand in software engineering there are different phases. I am going to explain what are those phases. Gain a knowledge of model methodologies, applicable tools. this in software engineering, we use methodologies and applicable tools. Two tools are uh, entity relationship diagrams and data flow diagrams are two tools of software requirement analysis. So not only the requirement analysis, in designing also it need. And you will have to you will study about use cases also, use cases and class diagrams. Today I am going to explain about use case diagrams. Use case diagrams also use case the a tool to support for to do the software engineering. One is other is project management. In every project, the project management should be there in civil engineering, mechanical, not only those for the software. Project management is there. But software project management, it is some different than uh, a civil engineering project management. We use now in this one only uh, few paces. Only few paces are there. Now actually, there's a called agile. Agile means these paces again linked to the another pace. These are the steps paces include the following stages. Concept and feasibility. First is the feasibility study. Identify marketing opportunities or an organizational need. Sometimes a company hire people may tell to the software companies, we want this software. What the software company should identify actually what should do, what software, what changes should do to this company, and the market opportunity and the organizational need. Actually, sometimes higher people need it, but actually organization not need it. Organization may need one another options, and then say organization suppose the software organization software is implemented, but if the market is not mature or not tally with that, this software will be obsolete or obsolete means not needed. It will become. So feasibility study is the major thing. There is another one, technical feasibility, because we suppose uh, uh, we market opportunity and organizational needs are okay, but suppose if the organization cannot buy necessary hardware and necessary hardware and pay to the software and pay to the workers, that also not feasible. So those things should be identified at the feasibility stage. Requirements capture. Now, then after the feasibility, the this the systems, the design, the proposed system should have some functions and should get we should get information about what are the existing data and information and the requirements of the company. So, in requirements capture base, all the data and there are suggestions which the software company should get all those things. Decide, and after capturing, the new system should be decided. Implementation. Then after that, this system after the design, uh, the software company should implement uh, the software in the company. Individual modules are written in source code, compiled and integrated to build a complete system. User documentation is written, and this the in I said about the data flow diagram. Little modules are there. Little modules are coded and then compiled. Compiled means these are executed separately, and also integrate those small modules, and uh, we should test. We should test for the errors and complete the design. And while doing those things, documentation should also write. And there are two types of documentation: user documentation and system documentation. All those two should be uh, written, but usually not happened. Only the user documentation is written. After that, implement the software, and the testing phase. Test should be do. There are several types of test. One is stop the earlier one and implement the system and the test on. And another one is parallel testing. Uh, uh, Earlier the earlier system should also uh, run, and the new system also should run parallelly. And then, if the new system fails, remove the new system. And if the new system is okay, and the old system should remove. Deployment and install the system or operations and maintenance. After the deployment is uh, after testing, the system should give to the company. And then operations and maintenance. After the implementation, there may be several levels, faults, and uh, new uh, patches should be included, like those things, operation and maintenance. Obsolescence is every system is uh, uh, every system is aging. Aging means uh, after some time it may not enough, or it is not work. So it is obsolescence. Uh, Normally software not break. It is obsolescence. Hardware may be break, and those will be damaged, but both will happen. Sometimes when you get the computer, sometimes broken. Sometimes those computers may not broken, but it is obsolete. You can't do anything with that computer. This is about software first phase, software second phase, software engineering, requirement engineering. Requirement engineering has elicitation, analysis, analyze, and specification and validation. Elicitation means how the necessary data obtained. Software elicitation. Requirements elicitation is concerned with where software requirements come from and how the software engineer can collect them. All the information should software engineer should get all the information and then what actually need the company.
So කලින් ස්ලයිඩ් එකට පොඩ්ඩක් ඊට පස්සේ ස්ලයිඩ් එක පොඩ්ඩක් දාන්න පුළුවන්.
Which slide?
ඔව්
Requirement elicitation.
ඊට පස්සේ පොඩ්ඩක්.
This one.
ඔව්
Requirement elicitation is concerned with where software requirements come from. Requirements come from. How these requirements come. That means normally higher level of the company request from the software company. But higher level people doesn't know about the lower details of the company. Suppose order processing. Lower level workers know about how those things happened. So how if this new system implemented, how it should go. The lower level people knows that, but higher level people will give the money. And like this, how first software company should software engineer should know what is the budget. Budget should be taken from the higher level people. The system, how the system should be implemented, that those information should get from the lower level workers. To collect those information, elicitation techniques. One is interviews. Interviews with higher people, middle people, like managers and operational management, strategic management managers, operational management, then workers, some lower level employees. The software engineers go and meet those people and take some take a time and get some interviews. Scenarios mean some examples, some small examples, and what in these one instance what will happen. Those are scenarios. Prototypes. Some prototype is some small system. Prepare a small system. Not the large system, a very small system. Suppose for 1 and 2 item. Item and like that, a very small system, and the outputs and the inputs, what should inputs and like those things. First, software company implement those things and present to the employees in the company. So they tell what should do, what are the drawbacks of this system and like that. Facilitated meetings collectively taking meetings. Observation is suppose workplace, just sit in the workplace and sort what they are doing. This is also one method to get the information about this. Just work around those in areas and observe what is happening. requirement analysis one, two requirement analysis data flow diagram, what I explained earlier. Another is use case diagram. I will explain first what is the how to draw the use case diagram. A use case diagram identifies business processes, identifies actors. Here you can see a simple use case diagram for telephone company, phone company. Describe the high-level function of and scope of the system. In use case diagram, first you have to implement you have to draw the boundary of this system you are going to implement. In a company, there may be several they need several softwares, but when you when a higher people person tells we want this software, there should be interfaces and there should be limitations, system boundary. Otherwise, what will happen? All the things software company will need to implement all the software. That will cost. That will not get any profit to the software company. So before that, system boundary should make. According to this simple use case, only handling message, handle call, message bill, only those things are doing. System boundary is this one, and outside the system boundary, these actors are there. Actors mean roles. What roles? Of some operators. One interacting with one person interacting with the cell phone company, cell phone. Cell phone actor may be not only the person. It may be another hardware and or software system also. And the external company also may be there. This according to this use case diagram, cell phone is an actor. Cell phone handling message, handle call. Handling call handling is not from the customer. It is the customer connect with only the cell phone. Okay. Now cell phone sends to the company messages and calls. And these are relationship. This cell phone relation with the this use case. These are called use cases. System boundary there, use case there, customer handling with and customer relation. This relations to this use case, manage bill. Phone company relate to these use cases, handle message and handle call. These actors are only external to the system. Describe the high-level functions and scope of the system. Scope is this system boundary. High-level functions are these are the functions: handle message, handle call, manage bill. Identify the interactions between the systems and its actors. Identify interactions between how interact with the actors to this use case. Describe what the system does and how the actors use it, not how the system operates internally. Uh, how it is, we are not going to draw in use cases how it operates internally, because what is happening to the in handling message is not necessary for use case. Actors. Actors specify role played by a user or any other system that interacts with the subject. Role. What is the role? They represent the roles played by human users, external hardware, or other subjects. Always outside the system interact directly with the interact directly with it by initiating a use case. Actors are initiate the use case. I will explain later what those things. Okay. Actor. Sorry. Give a meaningful business relevant name for the actor. If interact with an outside organization, it is much better to name it with a function rather than organization name. This one actor is airline company. Suppose it suppose we are going to implement a system to Sri Lanka. We are not going to write like Sri Lanka in the as actor. We write airline company. Just a general name. Name actors are with singular business relevant nouns. It is singular. Airline company, not airline companies. It is actually noun. Actor is a noun. We have to write it business relevant noun. We can't write like A, B, C like this. So we should write name of actor relevant business noun. Here you can see these actors are in left side, then this actor phone company actor is in the right side. These are for the left side actors are we call primary actors, and the secondary actors secondary actors are in the right side. Primary actors initiate the use case and hence somewhat independent. Primary actors are initiate the system because messages are handled. Messages are sent by cell phone. Call are sent by cell phone, and the customer initiate this. And then after interacting with the primary actors, secondary actors will respond to those interactions and those needs. Left side of the diagram quickly highlight the important role in the system. Secondary actors are used by the system, but they do not interact with the system on their own. In other words, secondary actors do not initiate any use case. Actor. Actor's model role, not position. When you write names for the actor, this front office execute, shift manager. Don't write those now. Um, uh, in hotel booth, front office executive and shift manager can make reservation. This is about reservation reservation. No, no. Those who the person those who reservation. Uh, we have to write reservation agent because this front office execute executive and also shift manager can both can reserve uh, this what is this hotel booth, and therefore we should write the common name. When we write common name, we can apply for those two persons. Not only those two persons, if someone other one involved, this person also belongs to this category, reservation agent. So something like reservation agent should use for actor name to highlight the role. Only the what role is doing. We have to write we have to give name only for the role, not for specific uh, officer. External systems are actors. If your use case send mail and if interact with the email management software, then of that software is an actor. Uh, the external systems, suppose um, from this software system generate some emails and send to other software, email management software. That was that outside system software, email management software is also becoming as a actor. Actor don't interact with other actors. We cannot directly put the relationship between actors. We can write directly linked with cell phone and the phone actor. All those relations are go through the use cases. But in one relationship, we can relate to the actors. I will explain later. Place inheriting actors below the parent actors. Place inheriting actors. Inheriting actors means cell phone is the in this use case diagram. Main is the cell phone. Cell phone interact with the customer. So customer is the second one. The main point is the cell phone. So cell phone we put left side upper, and then after that, according to the priority, according to the parent and child relationship, put the parent actor is upper and child actor should go to the lower, and should from sometimes this child actor also becoming a parent to the another actor. Now, can you understand do you have any questions? Can't see the screen. Is it? Hello. From which point you can't see the screen? Hello. Yes, yes.
We can
No.
see, sir.
Okay, okay. Now, are there any problems? Questions? Okay, I will explain another thing, another slide also. Then, yeah, I stopped. When you put the parent actors upper, it is more readable and quickly highlighted. Highlight the use cases specific for that actor. Use cases. Now these are the use cases. This is the actor, and these are the use cases. There are 4 use cases here. This is system boundary, and begin with strong verb. Here you can see open account, deposit funds, withdraw funds, close account. At the when you give a name for this use case, first type verb and now open account, deposit funds. Deposit is action, and the action for what? Funds. Withdraw funds. Close account. Name using domain technology, terminology. The domain terminology is here. This is related to the bank. You don't write like open A, open B like that. Write domain means if you are if the company is a bank, then relevant to that type or relevant to that company that bank. Place your primary use cases in the top left corner, and here you can see first open account, deposit funds, withdraw funds, close account, all are timely manner because first you should the customer should open, then deposit funds, and then you can either deposit or you can withdraw. Actually, before the withdraw, it should be deposit. And the close account is after all those things, you can close the account. So it is you have to first you have to write draw first priority, um, first use case in the timeline. Imply timing consideration by stacking use case. Stack is uh, this like this, one over another, one over another. Relations include there are several types of relations. This use case to another use case, there's two types of relations include and extend. This open account create tax entry. Another one, deposit funds extend calculate bonus. This use case is calculate bonus. This use is create entry. This when when a bank, when a customer open account, the tax should be included. That is a must. So between relations between these two are included because uh, after opening the account, the tax calculation should be there. So relationship between these are included. Extend is it is optional. Sometimes when you deposit a fund, bonus sometimes bonus may calculate, sometimes not. It is optional. Deposit over 10,000 or age over 55. If these if these conditions are satisfied, these bonus calculations are done. So this you should write, you should draw link between these deposit fund and calculates bonuses should be extended. Using functionality of another use case. Another use case as a part of its business process flow. Base use case to child use case. This is include this. This is parent. This is base case, use case, and this is child use case. This is parent. This is base, and this is child one. Relationship is depicted directed arrows having dotted line. This both include and extend are in dotted line. Sometimes in some places these relations are directly not dotted line. Just someone draw just arrow and line, not dotted line. That is depend. The tip of arrowhead points to the child still. This when you write include in before include and after include, you should type these two. These less than and greater than signs, two greater than signs and two less than signs. Arrow points to the base use case when using extend. But in include, arrow point should goes to the base to the child. In extend, arrow goes to the child to the base. Arrow point to the base use case when using extend. Extend can have optional extension conditions. This is condition. Generalization. Generalization means if there are two types or more types, not only the two, there may be three or more. Place order. There are two types of place orders. Phone order. Customer can order by phone through the internet. There are two types. So, relationship between place order and the phone order and the internet order are called generalization. Generalization sign is arrow is like this and not dotted line and direct line. Parent use case may be specialized into one or more child use cases. This is a specialized one. Phone order and in this use case, especially for attributes and actions are done especially for phone orders. This is especially for internet orders. Uh, uh, some details are common to both phone and internet orders. These are included in place order. The parent in most cases here is abstract. Abstract is um, abstract is in place order most of the time only define what is the child use cases. This actually you can understand more when you do actually example. I will tell what is happening, and please understand more when you do it practically. Because I also understood after, not by reading this, by doing this. A child inherits all structure behavior. Only the parent in most cases is abstract. A child inherits all structure, behavior, and relationships of parent. And in here the place order we include only the common to both phone order and the internet order. All the specialized things in the phone order and the internet order are included here. Children of the same parent are all specialization of children of the same parent are all specializations of the parent. Actually, this is common to both these specialized phone order and internet order. Therefore, we call this place order is general order and the specialized order. These are those phone order and internet order are specialized. How to identify actors? We can identify actors like from these questions. Who uses the system? Who restores the systems? Who starts up the system? Who maintains the system? Who shuts down the system? And all the answering of questions to these questions, you can get what are the actors. In requirement elicitations, you have to answer these questions. To get the answers, you have to use interviews, observations, and meetings like that. Identify the use cases, and then scenario-based elicitation process carries on by asking what externally visible, observable value that each actor desires. The following questions can be asked to identify use cases. Here, questions to ask about actors. Here, questions to get what are the use cases. We have to ask these questions. What functions will the actor want from the system? Does the system store information? What actors will create, read, update, and delete this information? Does the system need to notify an actor about changes in the internal state? Are there any external events the system must know about? What actors informs the system of those events? This is one simple example. Purchase fuel. Here, customer is a main actor. Adult customer is a one type customer. to the gas station, there are not only the adult customers are coming, there are any other customers, young girls and old persons, and all those things are women, men, like that. Adult customer is one type of customer. That is that arrow goes to the. It is like generalization. We call it as generalization. This act, from the actors to the use case, the relationship is just we have to draw the just line, only line. Purchase fuel, purchase lottery ticket. Adult customer may buy lottery tickets. In gas station, maybe lottery ticket counter also there. Now, most of the customers come and purchase fuel. Validate credit and print receipt. But when you buy any of these things, you should pay. This before suppose we are paying by credit card. The bank is now this validation process. The bank involves in validation process. So bank can state lottery now. Here lottery system also should relate should involve for this process validate, credit and print receipt. So this is a general one. This is a specialized one. These two are generalization arrows and the link relations. And when you purchase fuel, it should include the print receipt. This should be receipt according to this station, gas station. Printing the receipt also it is a must. So it is the link between purchase fuel and print receipt is included. Now, this use case, wash vehicle, that is not a mandatory one. That is not necessary one. Some customers may want wash vehicle, some just fill the fuel and go. So this is this line means like extent. Not only the purchase fuel, the gas station means wash vehicle. So it is a extent. Now I think there is before that I think you will understand this what is how to draw the use case. I think in a TMA you have to draw a use case diagram. Now last one is graphical user interface. I will explain briefly this one graphical user interface. Graphical user interface is system and the user, the interface between the system and the user. System is software system. It is inside the computer and the networks in the network system. Sometimes in one computer the one system is there, one program is there with the computer, another program in the another computer. But generally these are called upon backend. The user should see graphically easily understand interface between the system and the user. This is called the graphical user interface. When you sit down in the monitor, computer screen, you will see only the graphical user interface. You can't see the system, but you are interacting with this system with the user through the graphical user interface. Here you can see there are two types of interfaces: mobile interface, graphical user interface, and this computer screen. Some There are some difference from the graphical computer screen to the old screen. In mainly in graphical user interface, main components of graphical user interface are windows, icons, menus, pointers. Pointer is where the mouse goes. Menus is like this. Menus like this menu. When you are using MS Word, when you click here, like this is a menu. Icons, menu, pointers. Pointer, what is the pointer? The pointer is this arrow sign. That is the pointer. Icon is this one, and the window. Some small windows are there. Maybe you can in the desktop. There may be several more than one window. Control elements of GIMP called widget used to interact between user and the system. There are many common widgets. These are called widgets: tab, text box, label. This is a label. This is radio button. This is combo box. This is checkbox, like that. Those are called GIMP. Properties of graphical user. When we design graphical user, you have to consider color, foreground and background. Foreground is in this presentation. Now characters are color of character is black. Color of background is white. This relationship is sometimes if you include text color is black and the background is more blue, you can't see it. You can't see clearly. But with this one, foreground is text color. If the text color is black and background is white, you can visibly clearly. Size of the characters and all the images, because size may be there should be facility to change the size, because all the persons and some if there are problems in eyes, you can't see clearly, so the size should be larger, and some want size is the middle size, and some want very little small amount. Navigation is like this. You have to go. You can go this one to this one. This like this. Those things are navigation. One object to the other one. Shapes of the objects. Arrangement objects. resolution. Resolution is, I will explain in the next slides. Here this is foreground and background. Foreground is character, background is background. Size is in the here the size is screen size, resolution size. We can change this size to this one. Aspect ratio is 16 into 9. This 16 is this screen horizontal side to the vertical side ratio. 16 to 9. This is 16 to 9 actually. Pixels, number of pixels. Navigation. Resolution is pixels per inch. Now in a screen there are lots of pixels. Pixels is 1 point with red, green, blue included color point. Now this resolution is how many pixels per inch. If you consider the 10 into 10 pixels, this line is more clear. But if it is 5 into 5, that is 25 pixels, that is this line is not clear. That is the difference between pixel per inch, PPI. Color is this hue primary color. Now in screen primary colors are red, green, blue. This is red, green, blue. These are the primary colors of computer screen, but it is different to the paper. Primary color is red, yellow, blue. In computer screen, primary colors are red, green, blue. In between, when you combine red and blue, it becomes magenta. These are called secondary colors. Blue and green, cyan. Red and green, it becomes yellow. These are called secondary. Lightness. This one is lightness. Range from dark to full lumens. Dark means this one black. If you consider the color, this gray color, how gray color change from black to the white. This black to the white, this color, right, that is lightness. Brightness is relative to the lightness, darkness of a particular color. In one color, brightness is like this, 1 to black in one color. When you consider one color, black to white is called brightness. Saturation is from white to the full color. When you consider red, when you add some small amount of white, more amount of white, like that will change from in saturation. Warm color and cool color. A warm color we call warm color red, yellow, orange, like this. Cool color are green, blue, like that, like water and glass. warm color are like sun and fire. When we design graphical user interface, we have to think about those colors because with these colors, some uh, uh, attraction of users will change according to these colors. This is one optical illusion, Gaspard theory, continuation, closer, figure, proximity, similarity. You see here, this you can see only dots, but you think it is a line, two lines and several lines. This is like circle, half circle line. This is like uh, line, straight line, but these are not either straight line or circle, only dots here. These are all continuation, these are all illusions. A figure has no continuous lines, but it seems like continuous lines. These are like actually like triangles, but these are not actually triangles. We can see as triangles, but not actually triangles. Only the half circle, some cut, some corners, and three circles. Here also you can see this like a panda, but you can't this continuous lines. Foreground and background. Sometimes you can see two faces. Or else you can see vases. These are actually all are illusions. Actually not actually happening. You can see it. You can see it in different ways. When you design uh, graphical user interface, you have to consider those illusions also. Groupings. We tend to group objects when they are placed close together. It seems these are only dots, but we can think this is one group and this is one group. This may not actually happen, but we think it as two groups. Similarity. Similarity. These are circle lines. These are square lines. You will group. You can group these two lines are these two squares are in one group like that, but actually not. Uh, okay, thank you. Now, now today's day school is finished. Uh, uh, what are the problems?
නැවිගේෂන් කියන ස්ලයිඩ් එක පොඩ්ඩක් ආපහු දාන්න පුළුවන් වෙයිද දන්නේ
navigation කියලා කියන්නේ මේ object එකෙන් object එකට යන එක මේ විදිහට.
හරි හරි සර් හරි
These are included in all the graphical user interfaces.
හරි සර් බොහොම
What is that? Okay, some slides are not in our presentation. Actually, presentation I changed because you have to do the TMAs also, no? So I changed according to the TMA. Viva for no, we don't have. You don't have Viva for the TMA. TMAs no. only Viva available only for the mini project. This is not only one presentation. I will upload video. No, I will my marks to my now. My marks. What marks? Tumiraj. And then okay.